Thank you. So, hello. My name is Zyka. I'm here to talk about the rendering mechanism of the Vue.js framework. And let me better introduce myself. So, I'm a lead front-end software engineer at the company Camelot Lottery Solutions. And I'm also a happy co-organizer of the Vue.js Athens group, which is here in Greece. We organize meetups around Vue.js and we talk about Vue.js. So today I'm going to talk about the rendering mechanism. It's a bit more technical. I will try to go more, start describing more general ideas that compose the rendering mechanism implementation. So what we need to know about virtual DOMs, which is a basic part of rendering mechanisms for modern frameworks, is that it's a programming concept which is actually the virtual representation of the UI structure of our, let's say, HTML code, our template, and it's kept in the memory and it's synced into the real DOM. This concept was pioneered by React and it has been adapted in many other frameworks. There are various implementations and also Vue does the same thing. So the virtual DOM is more of a pattern rather than a specific technology. So there's no canonical way of implementing the virtual DOM. We will see how Vue does that in a few minutes. The main benefit of the virtual DOM is that it gives us, the developers, the ability to programmatically inspect and compose any UI structures we have in a more declarative way and leaving out any DOM manipulation that may happen to the renderer. So a typical HTML code would be something like that. I'm starting with an example just to better describe what I want to. So on the left, we see the HTML code of an HTML page, and on the right, we see the document object model, the representation of this specific code. So we know about I hope that you know about the DOM, about HTML and how this renders into the browser. But basically what I want to highlight here is that for the virtual DOM, in an environment with the Vue.js framework added, we would have such a template instead of the HTML code that we saw before. Somewhere we would have to put our HTML code in a Vue template, and this actually template will compile by the Vue.js framework into the virtual DOM. So basically the virtual DOM is just an object describing the nodes that we have added in our code. So a quick example, a very small one, would be something like that. So the virtual DOM needs all the details about the details of the element we have added. This is done by the framework itself. So the framework has a specific render pipeline. It gets the template, it compiles into a render function, it returns the virtual DOM, which is the virtual representation of our code, of our HTML code, and this virtual DOM is actually mounted into the real DOM. And in this case, this is the start of it, so this may happen a few times. But basically, as I said, Vue templates are compiled into render functions, and this can be done in a few ways. It can be done either ahead of time via build step, so we would need to have something like a command line interface in order to compile our template, or it can be done on the fly by using the runtime compiler with writing our own render functions. So ahead of time would be this template, so the CLI would compile our code into render functions, and if we would use some our own render functions, which means that we would have to use the API that Vue.js provides to skip the compilation step that is done. Then we could also have some more dynamic logic, and maybe we can opt for it if we want to use to take the full power of JavaScript. So the render functions would look something like this in Vue.js if we want to skip the compilation of the Vue templates. One more thing is how this virtual DOM is getting mounted actually into the real DOM. So when the render functions are getting invoked, they create the DOM nodes that are needed and based on our code, and these are mounted into the actual DOM. But probably in many cases we may have some dependencies and have reactive, let's say, dependencies that we want to show the updates on the DOM when things change. So for that, Vue repeats the same cycle. It runs something that we name reruns, and it updates the virtual DOM. It compares this new updated tree with the old one, and if there are necessary changes, then it applies those necessary changes. But let's take a better look on that. So by reactive dependencies, I mean anything that can be attached to the elements, such as attributes that may be reactive, or text that may be updated and need to be shown to the user. So in general, most of the virtual DOM implementations are purely runtime. So there is a reconciliation algorithm that cannot make any assumptions for any incoming changes to the virtual DOM tree. So it has to fully traverse and diff those changes, any props, anything that has changed on every V node in order to ensure the correctness. In addition to that, new V nodes are always created for them and always re-rendered. So this, as you may understand, may lead to memory pressure. So in order to avoid, this is a very criticized, let's say, aspect of the virtual DOM implementations in any framework, not only Vue.js, but Vue.js has a more specific reconciliation process so that it can have some optimizations and do this in a faster and a better way, in a more optimized way. So we always strive when we implement the virtual DOM to strive for declarativeness, but in some cases we also need to have some optimization processes, and maybe that's a trade-off for many frameworks. So Vue.js uses a hybrid approach. There is a compiler for virtual DOM, which is tightly coupled, and this compiler actually can take advantage of some generated code that Vue.js leaves behind, and knows how to better handle things and still preserve the capability to the user to drop down to any render function, of course, for more direct control. So let me go quickly to some of the features of the rendering mechanism. So Vue.js has something that's called static hoisting. It makes some decisions on whether to hoist a few things. It has the patch flags and the tree flattening. So regarding the static hoisting, there are parts of the code that may have dynamic bindings and others not. So when we have static content, this content and these elements are getting hoisted. And for example, in this slide, you can see that there are two elements, fuel bar, that actually have just the static text. So as you may have already understood, this will result in being hoisted and not being included into the render function. So this way, Vue is able to skip any diffing and any process that may add some memory pressure. The output of this on the generated code would be something like that. So you see on the top some constants that are the ones that are the static, which are hoisted, and at the end the exported function of the render function, which includes only the reactive, let's say, dependencies. And also you can do that for consecutive static elements, which can be grouped together, and Vue.js takes the assumption that these are they go all together, they don't need to get updated. So in that case, Vue would create just a const with an HTML string containing all those static elements, and leaving them out from the render function. One more thing about the patch flags. This is a very interesting feature. It's that it generates actually some numbers in the code. It leaves behind some generated code with some numbers. So in case we had, let's say, this HTML code that has some track dependencies, Vue at the end would create this kind of a function, which if you see there is a number at the end that it says 2. This is a patch flag, and this number means something specific to the framework itself. So if there are many, let's say, kind of the updates that an element needs to receive, this number will be merged into a single one. And basically this is done by using bitwise operations. So bitwise is extremely fast, and these patch flags are able to, and by using these patch flags, we're able to determine how the framework can do the least amount of work for updating elements. I've shared at the bottom the link for all of the patch flags that are available inside the framework. So these are the flags implemented inside the source code. And this is a very, let's say, good optimization that makes Vue, the Vue.js framework, very fast. Also, Vue understands when there's some kind of fragment in the template that has multiple root nodes, and in this way, it can take the assumption that these may never change, so it leaves behind again some specific, there is the specific patch flag for that, so it knows what it means, and it can also skip any reconciliation processes that may take. So, one more note that I would like to add, just about the generated code that you can see on the screen. There's this method, createElementBlock. You will notice that this one is a special method. I will describe why. So for blocks, what we mean, what Vue means as a block is a part of the template that has a stable inner structure. This means that there are no inner elements, that they do not display conditionally. So there are no, let's say, directives, such as the v-if directive that it's known for Vue to use, and the v-for. So for those kind of elements, it can know what elements need to track and what not, so that it can traverse a flattened tree of that representation of the UI structure, and end up to only do the dynamic changes on those elements that needs to do, so that it can avoid the extra effort of no changing elements. So the tree flattening reduces the number of nodes that need to be traversed, and any diff processes can be skipped. So Vue can only, let's say, traverse those nodes that are binded into the DOM. So that is all from me. I hope you found this interesting. Thank you very much.